Alright, so in this video, as you see on the top buffer, that I have enlisted 10 different things specifically related to Git, which I'm going to demonstrate, or you can copy paste, start copy paste and getting the effect of yourself. So these are the few of them are quite frequently used, few of them are for special cases. So I try to cover all this thing what I have enlisted, so it might come in handy. Okay, so I'm doing it inside Emacs. The top part is a buffer which is containing the list, and the bottom part is a shell running inside Emacs. You do not have to do these things. I'm doing it because it is open, it is there, so I'm doing it. You could do the things simply from the command line itself. Doesn't matter really. Okay, to give you some sort of sense, let's start with the first one. Okay, so for that I'm randomly choosing Git repository to show you some sort of effect of it. Okay, and if I go, okay, I'm inside Git repo. The first line, git log one line. So these are pretty standard command, right? That -s prompt you as it's written. Look at the top buffer, first point, string to find. Okay, so if I write boot just arbitrarily, so you could write anything sensible you want to find the specifics. It's a big repo, so it will take time, so unfortunately we have to bear it. See, this come out. So this many commits has got the word boot in it. Okay, so I'm canceling it. So you see, so you can find a particular string in a Git repo by running git log -- one line, then -s, capital S. Then you have to provide the string which you are looking for. Okay, so the next one is it is very interesting and very helpful to know that. So big projects has got a lot of maintainers and even more contributors. So not everyone is a maintainer, so there is a sub maintainer and then a lot of contributors, so the chain go up from the contributor to sub maintainer to maintainer. Okay, so the next two comments you see on the top buffer, point number 2 and 3, it's clearly state the author and the committer. Author, generally the person who wrote the patch, right, to mitigate a problem, to solve a problem, to enhance some efficiency, to do other trickery or other maneuver. The person actually thought about it, write about it, and submit a patch to the project. That person is the author of this. So you can easily find, let me selfishly show you the simplest possible way. And if I write author, my name, or I could have write anybody's name, whoever. So so you see, these things are coming. I mean, you can easily get that, but the thing is that um, I do not have the capacity. A lot of people do not have the or become a maintainer. So maintainer's job is to take the stuff from the author or contributor, from their sub maintainer, and then the maintainer basically committed to the project. That's how things work. So as you can see, two of my commits listed in the bottom part of the screen on the shell. So if you see, Jonathan Corbett, who has been committed these trivialities of mine uh, to the kernel. Okay, so so uh, so Jonathan Corbett is the committer of the patch, whatever I have sent it to the mailing list. So I'm just giving you an instance. Say, for if you're working in a business environment, your practice lead, program lead, or tech lead, whoever it is, or your manager, whoever is supervising you, you wrote something to solve and you send it off, and when the things come to push it to the actual project, so the person who is designated to fill in the stuff from the people, they're getting the contribution, so they will commit it to the repository. There is enough reason not to allow everyone to commit to the repository, specifically the public stuff, because uh, maintaining is such a important task. It takes a lot of things to count. So not everyone's cup of tea to understand the dynamics. So in business environment, people are specifically designated to understand the dynamics, so they have been given the right to commit to the particular project, so they do it. But using Git, it will honor the work you have done and you have sent it to the project, and the committer is merely taking your good work and submitting it to the project. So both the worker is very important. If the committer decided that your work is not good enough, I have got so many rejected because I did it stupidly, and I've been told that by the maintainer. So I don't mind, because those were the honest feedback. Because they are expert, they know what things require for the project. So it hard, but it certainly not upheld my ego. So in business environment, the same thing happen also. So the point I'm trying to make for all this long babbling, if you listen carefully, that the author and the committer both is important to get things through to the project. Here, my trivial stuff is committed by Jonathan Corbett, like many other stuff committed by some other maintainer in some other areas of the kernel. I'm just taking an instance of the project. Similar thing happen in business environment too. So basically, point number 2 and 3 on the top buffer, the author and committer, you can find out both of them, right? And both of them get credit for their work. So this is the beauty of it. Okay. So now I move on to the next part. So if you want the point number 4 on the top buffer, it says all commits to that particular file. So if I arbitrarily choose a particular file, git log, and cabled. Okay, so I choose a particular file which will show me all the commits to that file. See, all the commits are showing. You probably see that a lot of things has scrolled down because so many people have contributed to that particular file, and you'll see if you run that thing, git log -- then path to the file. Okay, that's what I did. Now let me do it one more time because I'm trying to and if I write cabled, okay, see, this many commits has been made to that particular file. Oh, and if I nullify it again, and if I put how many are there, see 53 commits are there to that particular file cabled. Okay, so you can check each and every commit to that file by running this if you're curious enough to know what is going on to that particular file. This is one way to find it out. Okay, all right, so the point number 5, to get the status of particular files, I'm looking at the point number 5 on the top buffer. So all I have to do, git log, and we have to use name status. Okay, then because it's coming out of shell, so I'm arbitrarily giving it's globbing, so it's looking for the .c extension. Because I'm in a repo, you could change it as per your liking. Use the globbing to, if your git project has different kind of file, you could easily filter it out. Because I'm in a project where things get dominated by this kind of file, should have find me these things. Let me see. So again, I ran this verbosely because you see what it's look like. Let me run it you again, and then if I do, and it will show me, see. So, and the beauty of it, you see, there is a things coming on the left hand side command. It's the M stands for the file has been modified. There will be A for addition. There are the symbols which will tell you. See, it's showing A, that means the file has been added. M stands for it's been modified. Okay, so this is a nice way to find out the status of the file. Okay, in a git repo by giving specifically name status argument to git log, and to find the specific filtered extension file. Again, please look at the point number 5 on top buffer, which is what I have shown to you in the bottom buffer where running in shell. Okay, all right, so the point number 6, so git log has got hyphen capital L, which show you the how a particular function evolves in a file. It clearly states that the pro forma of that particular argument, function name colon file path. Okay, so let me find a function, and if I go here in if I write, I'm just arbitrarily trying to, oh dear, oh dear. Okay. Okay. Now, say if I write git log and then provide capital L, and there is a function copy to user, and the file is ai.c. Okay, I'm in that particular file system directory inside the git repo. Otherwise, this section has to have the path, as you see on the top buffer. It's clearly says function name colon file path. If you are not in that particular directory, you are supposed to provide the path of the file where the function is available. Okay, the purpose of this command is to find out how a particular function evolves. Okay, so if I press enter, so did I do a mistake? Or if I really? Okay, so it's bad, I know. Okay, is bad, I know. What is the file I have seen? Okay, see, it's showing how you see, right, how this enlisting happened. So I don't think this will improve the situation, but if you write this, What? Okay. So here comes the difference, right? So with one line flag it doesn't work. So if you write point number 6 on the top buffer to find out or trace the particular function, here in this case I was looking at is bad inode is the function in a file bad inode.c. So as you clearly see, colon function name colon file path, that will show you how that function is evolved, or you can trace it out. Okay. Now the point number 7, the git tag is a wonderful way to segregate stuff from the main thing. So all the big projects, they generally use tag to keep things segregated and easy for maintainability. So the Git repository I'm in showing you this demonstration is no exception. It has got plethora of it, and it's happening every few weeks. So I'm arbitrarily choosing a particular SHA from the left hand side, okay, to show you the if I write git tag, okay, and if I give you contains, okay, write the argument contains, and the commit ID if I choose arbitrarily for the 530 58C 762A 62A FF. I just took a particular SHA of the enlisting and try to find out which tag this particular commit belongs to. That's why I passed contains. You see, look at the bottom of the screen. It shows us 1, 2, 3, 4 tags that particular commit is associated with. The contains basically mean how that particular commit is associated with tags. It could be one tag, it could be multiple tags. Because we are in a release cycle and this commit is going through all the releases, so I randomly choose commits. Likewise, you could do so, but to know which part or which tag it is belong to in a big project is sometimes come in handy, especially if you are trying to search something which is not easily. So this will give you a clue where you should look or your next move will be. It is as simple as that. Okay, it's a part of a search, you can say. So basically git tag contains and then the commit ID to find out which tag it is belong to. That's all, which is what the point number 7 on the top buffer is meant to be. Okay, the next one is there if you want to remove a particular file from git repo, all you have to do git rm cached and then the file name, whatever the file name you want to be. I'm here git rm cached, and if I write badino.c, it will be gone from the git repo, but it will be staying on the disk, it will be staying in it there, but it will not be part of the git repo. That is the whole point of git rm -- cached, then the file name. So if you want any particular file of your git repository not to be part of, you can remove that particular file from the git index basically. Okay, and this is the command you have to fire: git rm -- cached and then the file name. I'm not going to press enter right now. I could have, but I want you to practice. So the point number 8 is done. So point number 9, if you remove a file, okay, like in the point number 8, and if you wanted to find out when was the last time in that file was presented in that particular in that particular repository, then you have to use some sort of plumbing command. Rev list is like something like that, and it's basically finding out from the head, and then as it mentioned the file you have deleted, if you want to trace it out when that file was part of the git repo, so you need to use this plumbing command to find it out, and it will show you that. Okay, you could put an alias for this kind of command if you in a more humanly readable stuff, so you don't have to remember this plumbing command to find out the exact thing. And associated with that, if you want to bring back that particular stuff, you have to find out the commit. It will show you the commit. Then you have to simply, you see, git checkout, then deleting commit ID, okay, and then the file name. So it will bring back the file into the git repo. It's a two-step again. You have to run a plumbing command to find out when it was exist. It will show you the commit ID, and you need to check it out, that commit ID of that particular file, to get it back into the git repo. Point number 9 is that specifically defined in 2 steps. Okay, so last, the point number 10, it says clear, ignore changes to a specific file and reconsider tracking a file. Okay, so first let me go back. And first, I have something in my called freezing and unfreezing. Okay, you see I have these two aliases in my global git config file, which is what point number 10 on the top buffer specifying. If you specifically want to make restriction to a particular file not to be changed, okay, that means freeze that particular file. Think any of the file, for example, in your git repo, you just don't want to make changes to that particular file, so you have to run to update the index of the git database to make it freeze. I wrote it freeze because it make more sense to the entire command, right? So if I simply write git freeze and any particular file I don't want to make changes, so it could be done like that. Likewise, later you probably decide, no, I need to make a change to that particular file what I have freezed, then unfreezed it. That's why if you look at the bottom buffer, my global git config has got these two aliases, freeze and unfreeze, to a particular file in a git repo to get the update or not getting the update. This is the simplest possible way. You don't have to write the entire command or remember the stuff with the argument, so you can give it a sensible alias so you can call up by git. Pretty darn simple, but this is the simplest way to block changes to a particular file if the file is sensitive enough or static enough and must contain to inside the git repo, so you can make a change like this and do the stuff. Okay, so the last one, as you see, I have written bonus. Before git log, there is a simple subcommand is there, what changed. If I write since, as I mentioned in the top buffer, if I say 2 days back, just to narrow down some small thing, so instead of, as I mentioned, and in the top buffer you can clearly see it's a precursor to git log. Okay, it shows you the detail log difference, and you can narrow down the time frame since, and there is also an until argument is there, so you can narrow down the stuff in between those particular time, and it will change you the difference made to that particular stuff. So it will go on and show you all this stuff, right? So it might come in handy. So so these are the few stuff you could use to hover through or wade through inside Git repository. So it might help. So I thought these are handy commands inside a Git repository, so people who love to maneuver, love to wade through a large repository, if and only if they are not aware of this command, they might start using it for the benefit this provides to the user of the Git repository. Okay, so basically could freeze this particular screen just to see the stuff I have shown to you, so you could try it yourself in a Git repository. So it will help you to save some time and assess specific aspect of the repository you're trying to maneuver or wade through. Okay, so I hope it will be useful for some people. Thanks for watching.